Another key concern would be model inversion attacks, a very specific kind of attack, where the attacker uses output of a machine learning model to make inferences about the original input or training data that may have been consumed by the model already. This is done by the attacker through a series of probes to ultimately model what the model is trained on. And it comes to recognize patterns, features, and data sets. Of course, this is extremely troubling if you've got a private instance of a large language model that's been trained on private or sensitive data. The reason this attack is so dangerous is because of the sensitivity of data. For instance, if we were taking a look at healthcare applications that had patient data, we could end up in violation of regulations like HIPAA. And more importantly, we're just exposing people's personal lives. So we've got to do our due diligence in making sure that this exposure is limited. So the impact on privacy and compliance is a large one for organizations, especially those who are restricted by compliance requirements such as HIPAA previously noted, or GDPR, which penalizes for non-compliance and mandates protection of all personal data. So for mitigation, we can always implement some privacy techniques with our model to limit the amount of data that it's allowed to expose. In addition, we can also regularize our data and, of course, implement API access controls so that we aren't letting just anyone access the potential to gain this data.